Hey everyone. Today we're going to talk about a piece of internet history that is so fundamental you're literally using it right now to watch this, but you've probably never even heard of it. It's the story of a simple slash that basically saved the entire internet from collapsing on itself.
And no, I'm not being dramatic. Back in the early 90s, the internet was growing so fast that its core systems were about to hit a brick wall. We're talking a potential meltdown. So, how did we dodge that bullet? What was this brilliant idea that allowed the internet to scale into the global network we all depend on today? All right, let's get into it.
Welcome to Super Courseva. Unlock the secrets of the internet and master computer networking. Let's dive in.
To really get the solution, you first have to understand the problem. And to do that, we need to hop in the time machine and go back to when the internet used something called classful networking. And this whole system created a really specific kind of headache. I like to call it the Goldilocks problem.
See, back in the day, if you wanted to get online, you had to get a block of IP addresses, and they only came in 3 sizes. You had Class A, which gave you a wild 16 million addresses, way too big for almost anybody. Then there was Class B with 65,000 addresses, still way too big for most companies. And finally, you had Class C with just 254 addresses, which was often way too small. Nothing was just right.
And this quote just nails it. Just imagine you're a company, and you've got, 300 employees. You need 300 IPs. Well, a Class C is too small, but your only other choice is to grab a Class B and just waste over 64,000 perfectly good addresses. This wasn't just messy, it was creating a massive crisis. Because the solution people came up with was, well, it was a pretty clumsy workaround. It was a hack, really. And when you take that one little hack and multiply it by thousands and thousands of companies all over the world, you get an internet that is about to grind to a complete halt. So what was this hack? Simple. If you needed 300 IPs, you just buy 2 separate Class C networks. Problem solved, right? Well, not exactly. Because every single company that did this created 2 separate lines in the internet's master address books, the core routing tables. And that is the key. One company making 2 entries, not a big deal. But thousands of companies all doing it, that created millions of extra entries. The big, powerful routers that form the backbone of the internet, they were getting totally overwhelmed. Their memory was filling up, they were slowing down, the whole system was getting unstable. The internet was literally choking on its own address book. And then a hero arrived. It was this elegant, absolutely brilliant idea that didn't just patch the old system, it replaced it with something way, way better. It's called CIDR. And you can think of it like this. Instead of those ill-fitting, off-the-rack sizes, it gave everyone the ability to get a network that was a perfect, custom-tailored suit. So CIDR stands for Classless Inter-Domain Routing. And yeah, you pronounce it cider, like the drink, which is kind of fun. But the most important word there is classless. CIDR basically took the whole idea of Class A, B, and C networks and just threw it out the window. With CIDR, we're just done with the whole small, large, extra large system. Instead, you can define the exact size of the network you need. But how? What was the simple little trick that made this whole thing possible? It was this, a simple slash followed by a number. This is what we call CIDR notation. That little /23 on the end there, that's what tells routers precisely how big the network is. Just by changing that number, you can create a network of almost any size you can imagine. It's so simple, but so incredibly powerful. But the real genius of CIDR, the part that really, truly saved the internet, isn't just about making custom sizes. It's about how it lets us combine or aggregate smaller networks into one bigger one. And that has a pretty magical effect on those overloaded routers we were talking about. Okay, let's go back to our company that needed 500 IPs. Look at the table. The old way meant buying 2 Class C networks, which created 2 entries in those core router tables. But with CIDR, we make one single custom network. And the result? Just 1 entry on the router. We literally just cut the burden on the internet's backbone in half. But wait a second. Look at that last row. We went from 508 usable IPs to 510. Hang on, how is that possible? We combined 2 networks, and somehow we ended up with more usable addresses than we started with? That's not a typo. This is another piece of the CIDR magic. Okay,
Think of it like this. Imagine you buy your neighbor's property and you tear down the fence that runs between your 2 yards. All of a sudden, you've gained all that space where the fence used to be. It's the exact same idea with networks. See, every network has to set aside 2 addresses just for overhead, a network address and a broadcast address. When you merge 2 networks into one big one, you get rid of that border between them. The old broadcast address of the first network and the network address of the second one, they're not needed anymore. They become free to use. It's a fence removal bonus.
So, look, this is a cool story from the 90s, but why should you care about it now? Because CIDR isn't some historical relic. It is the absolute fundamental principle that holds up all modern networking, from the Wi-Fi in your house to the biggest cloud data centers on the planet. So, what are the big takeaways here? First, just forget about Class A, B, and C networks. They're dead. Everything is classless now. Second, that simple slash notation is the key that lets us build super efficient, custom-sized networks. And third, and this is the big one, it's that magic of aggregation that keeps the internet's core from getting bogged down, which is what allows it to keep on growing.
CIDR was this elegant, almost invisible piece of architecture that solved a gigantic scaling problem and let the internet become, well, the internet. And that leaves us with one final thought. The internet today is just exponentially bigger and more complex than it was in the 90s. So what are the modern versions of CIDR? What are the quiet, clever, invisible systems working right now, keeping today's internet from breaking under its own incredible weight?